Hi, I will be talking to you about um, algebraic reasoning, graphing, and connections with geometry. So, question one, we're talking about gallons of a gas and distance in miles. So, what we have here is the distance in miles is our x-axis, and our gallons of gas is our y-axis. So this little thing that you see right here is, the shape is the starting place of the vehicle. Place of the vehicle that was traveling zero distance, and how many gallons of gas it had in this tank. As the vehicle traveled, my x value increases, okay? So it increases, but my y value decreases because I'm using gas. Then I fill up my tank and it didn't even go nowhere. It just went forward. And as I traveled, the distance increases while the gas decreases. Next, we have the elevator, the rise of the elevator in a time. Right here is going to show us that the rise of the elevator, if you think about it, the y-axis, which is right here, as the floor is rising, and then you can think of your x-axis as the time goes by, because as the time goes by, floors are traveling. So it's like once you go up and up at a certain spot, it starts to, get shorter and longer in time. Next, we have time goes by as balloon bounces, and then we have the height of the balloon. Okay? Okay. So, here we go with that. So you see how it starts at the bottom, and it has one high bounce and keeps going until the gravity makes it bounce less and less, as you can see. So we'll look at that graph. You might think of the x-axis as the time, and it will increase. The range for the bounce is the vertical axis, and that decreases in the range of the boundary motion. Now let's look at the time of day and the length of flagpole. As the start of the day, the shadow, as we see, is going to get taller. As the day goes by, the shadow is going to get shorter. And then, of course, it'll get taller again as it moves. Here we are with this. And this is talking about our functions, okay? So that's what we're talking about, our functions. And we always want to know what our function is, okay? And as we can see, it says our function is a relation in which each element from the domains is paired with exactly one element from the range. In other words, each x value can only be paired Okay, so here's our x. There's our x value right there. And it's showing us here that with our x value, that we have 0, 1, 2, and 3. And our f of x equals 3x has 0, 3, 6, and 9. And our g of xx is x plus 8. So as you can see here, it is it increases by 3. Okay, so on the g of x is also increased by 3, and it's 8 plus 3 is 11, 6 plus 8 is 14, and 9 plus 8 is 17. So as you can see right here with our graphs, that our graph showing that that's what it is, because if you go right here at the x value at 2 and you go up, you see it's going up by 3, 1, 2, and 3. Okay, so that's that one. So next we're going to talk about, we're going to show our line segments, okay? And we're going to do, as you can see, that we have our x value and our y, and we have 3, 4, and 5. So as you can see, we're given the two, our line is going, as we can see, our line is going up to the right. Now let's figure the slope up. So you'll go up 1, 2, 3, and 4, and then over 2, okay? So 4 divided by 2 is going to give us 2, so that'll be our slope for that. And for B is gonna, this one is gonna look at, as we were given 2 plots, okay? 5 and 8, 5 and negative 8. And so we can just plug in our values into the formula, okay? Because right here it's gonna show you the vertical line right here. This is our vertical line. So we have 5 of 8 and 5 of negative 8. And we got our slope is m equals negative 8 minus 8 over 5 minus 5 equals negative 16 over 0, which is undefined. The denominator is undefined. And then we have our formula, which is m equals y squared minus y1 over x squared minus x1. Here's another one of our formulas. We have x and y. We have negative x. We have negative 1, negative 2, negative 3, and negative 4. Our y-axis is negative 4 and negative 13. So we will use our, here our line is going downward, okay? Into the left. And we know this because of negative on x and y-axis. So let's figure the slope. So you see the formula we have here, mf equals y squared minus y1, x squared minus x1. So we have our points, which is negative 1, negative 4, negative 4, negative 13. So we have m equals negative 13 minus, in parentheses, negative 4 over negative 4 minus negative 1. So m will be negative 9 over 3. That will make our slope 3. All right, let's head on over here to our other functions to show the difference in graphs. So x has to follow the functions of y equals x squared, y equals x squared plus 7, and y equals x squared minus 7. So it has to follow these rules, okay? So when we graph the parabolas, we can see that they all have the same curve shape, but they are on different spots on the graph, as you can see. They have the same curve shape, but they're different. There's different spots on the graph. So as you can see that they're all open up. Okay, so that's the negative, negative, but these are positive, how they open up. Here we're asked to show and explain the equation of the line through the given point that is perpendicular to the given line, okay? 6 is on the x-axis, -1 is on our y-axis. To figure the slope, we need to use the formula, okay? Which our formula is y minus y to the first power equals m times x minus x to the first power, okay? So m is our slope. All right, so we will solve this, and you will get y equals -3/4 x plus 5. So the m will be, your slope will be -3/4, and your reciprocal slope will be 4/3, right? So y minus -1 equals 4/3 times x minus 6. So then you'll do the distributive practice, and you'll do y plus 1 equals 4/3x minus 8. Y equals 4/3x minus a minus 1. And then you have y equals 4/3x minus 9. And that's how we have this answer right here. All right? And the graph shows you where how it's going straight up. Our next one is, we're given 2y plus 9x minus 5 equals 0. And our points is 0/3. So I need to solve for y, okay? So I take 2y plus 9x. 2y equals 0 minus 9x plus 5, and I divide both sides by 2. So it'll be y equals -9/2x plus 5/2. This gives me my slope. But in order to solve the perpendicular slope, we need to do the reciprocal of 2/9. So the reciprocal, I'm going to use my point plot, which is the S0, 3. So it's going to be y minus y to the first power equals m times x minus x1. Y minus 3 equals 2/9 over x minus 0. Y minus 3 equals 2/9x. Y equals 2/9x plus 3, and that's how we got that. So here we have, there are two axes, okay? X-axis, which gives from left to right, y-axis up and down vertical, and they meet right here in the middle, and that's called our origin, okay? So we said that the origin has a circle of 0, 0. And that's how you get perpendicular, because you're going to put your lines there. And so you have y minus parentheses minus 9 equals 0 minus 0 over 0 minus negative 9. And you get y equals negative 9. All right? So that's that.